Hey everybody, welcome back. Bet you never expected me to move the webcam. Haven't done that before. I'm always trying to find new ways to terrify you. Well, that's way too high now. But welcome back. My name is Ryan. This is day 7 of Advent of Code, which means that we are 1 week into solving all kinds of beautiful problems with Elm. So we've got 12 total stars, 2 stars a day. Um, and we've been doing them all together from scratch. We've been putting our puzzle input in here. That's one Z too many. Hit compile, and we've been seeing the answers. We've been slowly transforming them over time using Elm's pipeline operator. So good things have been happening. What I want to do is dive right into day 7. I haven't looked at the problem yet. We're going to take a look at it together for the first time. We're going to read through it and see if we can knock out part 1 and part 2 and make it one solid week of Elm goodness. I'm going to take a sip of some hot chocolate first while I click this button. Hooray! All right, we got some elves. They're trying to go up or something. I don't really know the plot. I lost the plot about one day into these things. But today we're dealing with camels. Okay. Day 7, camel cards. Your all expenses paid trip turns out to be a one-way 5-minute ride in an airship. At least it's a cool airship. It drops you off at the edge of a vast desert and descends back to Island Island. Did you bring the parts? Blah, blah, blah. Did you bring the parts? Camel and something. The parts for the sand. Yes, come with me. I'll show you. She beckons you on the camel. A bunch of words. Because your journey will take a few days, she offers to teach you the game of camel cards. Camel cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. Yeah, I like that joke. In camel cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards, labeled 1 of A, K, Q, J, T, 9, all the way down to 2. So sounds like a standard 13 cards. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. Every hand is exactly one type. From strongest to weakest, they are 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, or high card. So 2 pairs when you have 2 pairs of 2, 1 pair is when you have 1 pair of 2. Well, makes sense. Hands are primarily ordered based on type. For example, every full house is stronger than any 3 of a kind. If 2 hands have the same type, a second ordering rule takes effect. Start by comparing the first card in each hand. If these cards are different, the hand with the strongest first card is considered stronger. If the first card in each hand has the same label, however, then move on to considering the second card in each hand. If they differ, the hand with the higher second card wins. Otherwise, continue with the third card in each hand, then the fourth, and the fifth. So 4 threes and a 2 and 4 A's and a 2 are both 4 of a kind, but 3 is stronger because the first card is stronger. That's weird. Even though you have 4 aces, looks like the 3 is stronger. Similarly, 77888 and 77788 are both a full house, but 77888 is stronger because its third card is stronger, and both hands have the same first and second card. I think they just made those rules weird just to make it easier for the computer to handle. To play camel cards, you're given a list of hands and their corresponding bid, your puzzle input. For example, 32T3K 765 and all this stuff. This example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, the second weakest gets rank 2, and so on the strongest hand. Because there are 5 hands in this example, the strongest hand will have rank 5, and its bid will be multiplied by 5. So the first step is to put the hands in order of strength. So we got a 1 pair, a 2 pair. Because these are both 2 pair, this one is lower than this because K is higher than T. T55J7 and QQQJA are both 3 of a kind, but the Q is stronger, so it gets 5 because the Q is bigger than the T. Now you can determine the total winnings of this set of hands by adding up the result of multiplying each hand's bid with its rank. So 765 times 1, 220 times 2. We're basically taking those bids as they're associated with each thing. And then we're going to add those up multiplied by their rank, figure out the total winnings. So what are the total winnings for our unique puzzle input? So our puzzle input is going to be a huge list, but just to get started, what we're going to be doing is we're going to take this starter template, we're going to call this B7, 1. Starter template is available in the description if you want to start where I started here. It just does a little bit of dark mode stuff and includes the debug toString and HTML text function, which just helps us see the output on the right side. So if you want to pause here and follow along, feel free to do that. But I'm going to dive right in by grabbing this puzzle input and starting to turn this raw text into some structured information. So here we have a string with new lines separating all of our lines. So start by doing string.lines to break each individual card or each individual hand and its bid into separate numbers here. And then what I want to do is use filter map to convert these guys into something structured. So we'll say to hand, I guess. So hand is going to take in a string and it's going to return maybe hand, and if it fails, we're just going to filter it out of the list. So if we can't parse it, something wrong. So we could use words. We could also use split spaces. I'm just going to use words. We're going to take each line, call this line. And we've done similar stuff in previous videos, so I'm kind of going a little quick through this one. But these are going to be the five card string, and this is going to be the bid. Let's take a look at what they call this. So a bid. These are called hands. What would I call the group? 5 hands. Each hand is followed by its bid amount. Okay, so they're calling this other field a hand here. So I guess this is like the hand string. Call this hand info, just to distinguish something that has the hand and the bid from something that just has the hand. So type alias for hand info. We could start by just saying that a hand, oops, is just a string, and a bid is also just a string. So this would be a good place to start. And we're going to say if we can get the hand string and the bid string, we can return one of these here. So what we're going to do below, let me make some space. So we're going to say this hand equals that string that we got. This bid is going to equal that string that we got. And in this case, we were able to parse the information, so we're going to return this wrapped in a just to say that our maybe has a value. But if we have any other size, so like if we have multiple spaces or like multiple numbers, we're just going to say that was an invalid line. So if I compile here, oops, we're going to want to use the right name function, turn this into hand info. What you'll see is now each of these lines is split and organized. We've separated the bid, like 684, from the hand, like T55J5. It would be nicer if a bid was a number. So rather than saying that that we're going to be storing strings, what I'd like to do is say this is going to be an integer, and I'd like the hand to be like a list of, well, we can keep it as a string for now. I was going to say a list of characters, but we can turn into a list of like card values if we want at some point. Maybe we'll do that. List of card values. So ultimately, hand info is going to be okay if we can take the bid and turn it into to a number. And because toInt returns a maybe, we're going to want to use maybe map here. Maybe hand info. Give it, let's just start by, let's do this one step at a time. We're going to start by saying you can take the hand string as is, and then hand info needs us to pass in the result of this maybe operation. So when I compile this, you'll see that the bid loses the quotes. It is a real integer. And then what we want for the string is we're going to want to do a list.filter map here on the hand string, which sounds like hamstring. It's a different thing. We're going to say to card value. So we're going to say that there are such things as card values. Make a separate data structure down here. And card value is going to be basically a number. It's going to be A or K, J, sorry, A or K or Q, or it's going to be like a number card. I guess T we could include, or we can have some like number. So if we wanted to parse each character here, what we could do is we could say string, turn this into a list. Just do this in a map too. This is kind of hard to do. We're going to take this hand string. We're going to use string .toList to turn it into a list of characters. And then if we run each of those characters through this filter map with a toCard value function, we can expect that if a character comes in, we're going to spit out a maybe card value on the way out. Because not every character in the entire, and not every letter we can type would be a valid number. So there are certain characters that would just be invalid input. So to give you a more concrete idea of what I mean by that is A is okay. That would map to this value A. A is okay. That would map to this value K. Q is okay. Value Q. J is okay. T is okay. Here I'm trying to figure out, should I just treat all of these as numbers? Like, instead of saying like T maps to T, and then 0 max, or sorry, what is it, 9, 8, 7, all the way down. We have 9, let's see if I can get more, 8, 7, 6, 5, 4, 3, 2. I wonder if a better way to do it is to say card value is just a number. And rather than having these special letters that we're going to have to convert to numbers at the end, if we just say 10, 11, 12, 13, so if we do that, oops, then we won't have to do anything a second step. So I'm going to make a little alias here called card value. And if we get any other character, it's going to be total, just invalid input. So we're just going to call that nothing. So here, instead of our hand being 3, 2, T, 3K, we have 3, 2, 10, 3, and 13. And so each of these numbers is going to represent its value. So what we can do is we can figure out, hey, how many duplicates are. We can kind of group by the value, and then we can say what's our biggest group. This is a 5 of a kind. This is a 4 of a kind. Let's see where we're at. So we can say type rank 5 of a kind, 4 of a kind, 5 of a kind, 4 of a kind, full house, 3, 2 pair, 1 pair, high card. Fine. Full house. Two pair, 1 pair, just a high card. So these are the different ranks, and they're each going to be, worth something. So if we had 2 ranks, we can compare which one's better, and that's how we'll kind of sort sort our list. So what I'd like to do is if we take hand info, it would be nice to know. It'd be nice to append the information about like what. I'm kind of curious, like if we can just add like the rank right here and say like, what is this hand? Is this a 2 pair? Is this a 1 pair, etc. Let's like put that in hand info. And the way I'm going to do that is I'm going to just hand say just rank, 2 rank, right, give it a hand. Use a map 3 now because hand info has 3 fields. So these map functions, maybe has a map functions, list has these map functions. This map 3, this map 4, etc. You're going to see that in a lot of different Elm functions once you get used to the core library. So I'm just going to paste this in here and just add an annotation so that I get really nice error messages if one of my assumptions was wrong. So format this. Something. Now all we have to do is add this 2 rank function. So we're going to write some code down here. 2 rank is going to do is take a list of card values and determine what's the rank for that. So by default, you could say these values are always like a high card. That might be one way that we implement this. So rank is the last argument, so we got to give rank at the end. And the second argument is bid. That's why it needs to go in the second spot. So here I'm hard coding always a high card, which isn't right. That's not actually the logic we want. We want to come back here and we want to add some logic to help us figure out is it 5 of a kind. So let's just start by detecting 5 of a kind. So something is a 5 of a kind if it'd be nice to like group the numbers, like group these numbers together and figure out like what's the maximum set. So there's a really nice Elm package for this. And list extra, I think there's a group by function. So I'm gonna click view docs. It's gonna get really bright for a second. We're gonna look for is group. What group allows you to do is just give a list of numbers and it's gonna give you grouped numbers here. So we can figure out like how many of each thing there are. So there's I don't want this because what this is doing is it's separating the ones. For to do is to just go through the list and then, oh, here we go. This is a gather equals. This is the function we want where we're going to give it a list and it's going to say, okay, no matter what the separation is between things, we're going to want to group similar numbers together. So notice that this one, I'm going to zoom in a little bit. Notice that these ones are separated, but we're still grouping them together in this first cluster. And you'll see this weird a comma list a. This is just a non-empty list in Elm. This is a way to represent a list where you say, I promise I'll always at least have one value, and then here's the rest of the stuff in the list. So this is kind of like a way to guarantee that you're going to have at least one value in everything. So what we did is we installed that. If we want to use it, we're going to need to import it. So list.extra, it's going to be what we import. Do is we can say let oops, it's going to be a list of card value, list of card values. Oops. List.extra.gather. Gather. Turning here. So what we want to do is figure out with these groups, if we take a look at this again, we can find the lengths of all of these groups, and we can use these lengths to determine like what is the what's the biggest thing we saw. So let's just do this one step at a time here. I'm going to comment out this type, and I'm just going to return the groups as is. And what I'm going to do here is say I'm not returning to-hand info anymore. I'm just going to comment out all this code that we had. Maybe I'll just comment out this part. Make our lives a little bit easier. We still want this part to be able to pass in hand info. What we can do instead is we can say let's return just the ranks. So I'm going to do that, and I'm also going to just grab only the first item so we can focus just on the 3-2 T3K situation. So here what we're seeing is that we found 2 3s, we found 1 2, we found 1 10, and we found 1 13, also known as a king. So by doing this, we can map these to just figure out the length. So how many of each number did we find? So if we take this, oops, we say list.map, and we have our tuple, we're going to have like an item, and then we're going to have a list. The length is just going to be the length of that list plus 1 because we're always going to have an item in here. And so we can even use an underscore to say that we're not going to use that variable. We're just going to ignore it. Oops. Sometimes weird stuff happens with these comments. Ellie. So I just add random spaces, and that fixes it. So what's cool about this is now it says we have a single pair that we found, and then we found just 3 numbers that didn't have a pair. So we can use this information and say, what is the maximum, or like basically look at these numbers and say like, does it include a 5? If this list includes a 5, then we found a 5 of a kind. If the list includes a 4, then we found a 4 of a kind. If it includes a 3 and a 2, we found a full house, etc. So we're going to take this information, and this is going to be, we're going to call this groups again, but this time it'll just be a list of ints. So we can say if list.member 5 groups, then we have 5 of a kind. And then we can continue and do more logic for the other scenarios. So let's just kind of go through those scenarios together. If we find a 4 in this count, then we found a 4 of a kind. We found a 3 and a 2. The only way we can get a full house. Oops. And let's just say for now, everything else. See here is we've hit this like else case for now, because this first item here, it wasn't 5 of a kind. But if we did 5 5 5 5 5, that would give us 5 of a kind. If we did A, that would give us 5 of a kind. If we picked a random number here, made it different, this would give us 4 of a kind because it found groups of 4. So just to show you one more time here, if we just return these groups as is, notice that in this scenario, we got 4 1 because we found 4 A's together and we found 1 5. Here we just are going to get just a list with 5 in it because we only found a group with 5. So we're going to be able to see that our logic's working as expected. So we got to keep going. That was just all the way down to full house. We need to also say else if else if for 3 of a kind, 2 pair, and 1 pair. So 3 of a kind, 2 pair, 1 pair, and then the final else will be high card. So let's do this one here. So for a 3 of a kind, if we got past this, else, that means it couldn't have been a full house by the time we get into this condition. So we know that full house was already checked. Here, if we found, this is going to be, if we filter the groups down to those that equal 2, if we found 2 2s. So this is going to be a little bit different. So what I'm going to do is I'm going to say list.filter, give a little cute Elm thing here. I'm going to say we're only going to keep the 2s, and we're going to find the length. That length equals 2, that means we found 2 pairs. So if we only keep the 2s, then we should have 2 2s. And then here, this is a simple one. This is if we have a 2, then we know we found a 1 pair. So let's just test all these out. Sorry, 3 of a kind. So here it's saying we just found 1 pair, which is true. We only found a 3 and a 3, and that's the only pair we had. But if, let's say there were 2 T's and 2 3's, hopefully this would say 2 pair. If we found 3 3's, we should see 3 of a kind. Cool. And then if these were also the same, we should see full house. And then if they're all different, 1, 2, 3, 4, 5, we should see a high card. So I think all this seems to be working okay. So what I'm going to do is put this label back on. Now we actually are returning ranks, so that's good. I'm going to return the full value that we said we were going to return before. I'm going to put this label back on because we are returning hand info again. And I'm going to get rid of this list.head. And what you'll see is for each of these, we were able not only to find the bid, to take the hand values, but we're also able to find the rank. So it looks like we found 1 pair, 3 of a kind, 2 pair, 2 pair, 3 of a kind. And I think that matches correctly with what we'd expect. There's our 3 of a kind. We have our 2 pair, yep, 2 Ks, 2 Ts, 2 Ks, 2 7s, and then 3 5s, that's another 3 pair. And what we need to do next is we need to sort these hands based on their rank. So what we're going to be doing with that is we are going to be applying the logic that they said to use, which is sort by rank. And if there's a tie, you're going to work your way left to right and find the first thing that has a bigger rank and choose that one. So if we do list.sort by, we can use a sorter. Sort with. This is going to sorter function. So a sorter function is going to take in a hand info. It's going to take in another hand info, and it's going to return an order. So greater than, less than, etc. So if I have hand A and hand B, I'm just going to call these A and B. We might return, basics like equal. If they're both the same, we would return basics less than. They're different. So this wouldn't have any effect. What we want to do is we want to figure out which one has a higher rank, and then if there's a tie, we'll go into the tiebreaker. So the way we can figure out what has a higher rank is we can say which one of these has a bigger index. What would be a good way to do this? Let's just list out the ranks in ascending order. Ranks ascending. These are actually going to be descending. So here, really want to take all these, something like that, and then instead of using these pipes, we're going to use commas. And so now we've got our ranks ordered from most valuable to least valuable. And so we're going to loop through our ranks. And if any of these ranks are found first, then we'll be able to know which one had a higher rank. So we have a.rank rank A's index sub element index. So here I'm going to give it the rank, I'm going to give it the list of ranks, and it's going to spit out if it found a match, where it found that match. So here if I give it 1 and I give it this list, it's going to say at index 0 I found the 1. So we're going to use this list extra element index to return the index for the first occurrence of that rank that we're looking for. So here we're going to say list.extra element index. I'm going to say a.rank, and then I'm going to give the ranks descending. We'll do the exact same thing for rank B. What I want to do is say if rank index A is less than rank B index, that means that A had one of these earlier ranks. If the index was lower, that means it had something like 5 of a kind, whereas B had 4 of a kind or full house or something worse. So if rank A is less than rank B, we're going to say that rank A is greater than rank B. Otherwise, say if rank A was greater than that, we'll say that it was less than. And then finally, oops, I need if here. And then finally, we're going to, this other scenario is that they're equal, the ranks are equal. So what we want to do in this case is we want to loop through each list, and we want to stop as soon as we find a different number. So I'm going to do something kind of weird here. I'm going to do a list map 2 with compare, and I'm going to say a.hand, b.hand. What that's going to do is that's going to give me a list of like equal. So let's take a look at this, for example. If it was comparing 3 and 10, it would give me a list where it compares each of these values. So it'd say 3 is less than 10, 2 is less than 5, 10 is greater than 5. So if I'm just going to put this in the comments above here. So I think it'll be easier to just show you in a comment than it would be to show you by modifying code that we have. What we'd end up with here is less than, because 3 is less than 10. Then for this next one, so for each element in this list, we'd get less than here. Here we would get less than because 2 is less than 5. Here we would get greater than because 10 is greater than 5. Here we get less than, and here we get greater than. And we can use this new list that we created. This is what list map 2 would spit out if we ran list map compare on these two lists, on A's hand and B's hand. So what we can do is we can take this and we want to find, if the first thing we find is a less than, we're going to return the less than. And if the first thing we find is a greater than, we'll return the greater than. So what I'm going to do is I'm going to filter this list down. This is going to be kind of crazy where it's not equal to equal. So I don't want to keep anything. I guess I could do a find here. List extra find. Give me the first element that you find that is not equal to equal. And then that's what I want you to return. And otherwise, if you couldn't find anything, let's say every number was identical. We got equal, 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 equal. That's totally fine. We're just going to say fallback behavior is that means that these two hands are identical, their ranks are identical. So in that situation, we're just going to say it's equal, and that's totally acceptable. Element index. Oh, say maybe down with default. Here, we shouldn't run into this scenario because every rank was covered in our list. But if not, we're going to give it superpowers. We're going to make it default to 0. So what we're seeing here is 1 pair, 3 of a kind, 3 of a kind, 2 pair, 2 pair. That's not right. 1 pair, 3 of a kind, 3 of a kind, 2 pair, 2 pair. I think this order isn't right. Oh, sorry. I used the A's rank twice. Copy paste mistake. It's like that doesn't make any sense. Here we go. So here we're seeing 1 pair, 2 pair, 2 pair, 3 of a kind, 3 of a kind. So it is working in ascending order. So what's funny about this is it's doing the opposite of what I want it to do, because we're going to want to number these things. So we're going to want to say the thing that's ranked 1. Actually, maybe this is perfect. The thing that's ranked 1 is the lowest thing, right? So 1 would be multiplied by that first number, 7. Okay, this is great. So we multiply we take the index of this and multiply by the bid. So 765 times 1, 220 times 2, 28 times 3, 220 times 2, 28 times 3. Yep, 684 times 4, and 483 times 5. So we're almost there. We're over at the point where we have bids, we have an order. So what we can do is we can say, I've already sorted these. But now I only care about the bids. We can throw away all the other information. So now I've got all these bids. What I want to do is do a list.indexed map, where I take index, and I'm just going to do index plus 1 times the bid that I have. And so now you'll see when we do all that, when we triple 28 and we do all that work, we're left with a list of numbers that we can just add together with a list.sum, and we get 6440. Is that right? 6440. So that looks like that's the correct answer for this puzzle input. So what I'm going to do is I'm going to format this here. I'm going to save this. I'm going to do a little thing here, structure the bid, just to be fancy. That should give us the same answer. It looks like it does. So I'm going to save this as part 1. I'm going to pin this here, and I'm going to duplicate it. So that was our part 1. What I want to do is take our puzzle input, replace the sample input with it, and see what number we get. So it looks like the number we got was 2536, 38586. Those are our total winnings. So what I'm going to do is plug this into part 1, submit, and it looks like that was right. So that gave us 1 gold star. Perfect. So all these problems, they have some twist at the end where they add some extra nuance to the problem. Hopefully this part 2 will be easy, but let's see how they change the problem up. Oops. I love how I clicked it so loud you could hear it, but it still didn't work. All right, part 2. To make things a little more interesting, the elf introduces one additional rule. Now J cards are jokers, wild cards that can act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest individual cards, weaker even than 2. So the other cards stay in the same order, A, K, Q, T, all the way down to 2, but then J's at the end. So J cards can pretend to be whatever card is best for the purpose of determining hand type. For example, QJJQ2 is now considered a 4 of a kind, because the J acts as like a wild card for the queen. J is always treated as J, not the card it's pretending to be. So J with 3 Ks and a 2 is weaker than the queen with 3 Qs and a 2, because J is weaker than Q. So that makes sense. Now the above example goes very differently, because here you'll see this is still a 1 pair. This one is a 4 of a kind because these are all 5s. These are all 10s, and these are all queens. And then this is still a 2 pair, it looks like. And because T is lower than Q is lower than K. It's rank 3, 4, and 5. Of the new Joker rule, the total winnings in this example are 5905. So if we treat the J as a Joker, what are our new winnings going to be? I think this is going to be an easy one. Maybe I should knock on wood for that. I don't know if that's going to backfire for me saying that. But I think this is going to be straightforward. All we're going to do, let's clear this out. All we're going to do is we're going to go back a little bit to where we were at hand info and make a few changes. So back at hand info, we were doing two things. One, we were taking the list of card values, and we had this toCard value function, which was mapping cards to numbers. It looks like this J is no longer a 11. We can leave the rest. Oops. We can leave the rest at 12 and 13. It's not a big deal. The important thing is that A is bigger than K, is bigger than Q, is bigger than T. Or we can just treat them like this if we want. But the important thing is that we treat J as the lowest possible value. So in the grand order of things, J needs to be moved to the bottom. So that's step one. Step two, let's see if we compile that if we end up with our J's. Now we're seeing ones. Yep, we're seeing one show up over here, which means that that part worked. And then the other thing that we want to do is we need to recalculate that rank function. So this is going to come back to our groups. We're going to be able to sort by, we're going to be able to distinguish cards that had J's, or sorry, we're going to pull the J cards out of the groups. We're going to keep the cards that are fixed. So we're going to kind of separate the wild card from the regular cards. We're going to get the groups. We're going to figure out what group had the most numbers, and then we're going to try to get the highest rank based on that. Because a 4 of a kind is always better than a full house, I don't think there's any special logic. I think we always want to pair J's with the card that shows up the most. I think that'll always give us the most points. So like if we had two J's, for example, and a 3, 3, and a 2, it would always be better to go with all threes than it would be to try to make a full house, because 4 of a kind is better than a full house. Great. Okay, so what we're going to do is we're going to change how toRank works. And so I'm going to do that thing we did before, where we comment this stuff out so that we can kind of walk through it step by step. And actually, this code is going to stay the same. So this is going to be toRank from groups. This is going to give us a list of card values again and give us a rank. But this will just take groups as the arguments. This is actually a list of ints. Let's go more like card counts. Whatever, we'll just leave it in it. But what's going to change here is we're going to want to be printing out as we go this toRank thing. So I'm just going to comment out annotations that might leave that there. We're going to go toRank here. Hand info is fine. Filter map is fine. And we're just going to focus on this first output. So in our first output, we see 32T3K. And what it's saying, let's actually go back a little bit. Let's go back before we decided to group these together. So we can leave this alone, take that off for a sec. What it's saying is we found a group of 2 3s, a group of 1 2, a group of 1 10, and a group of 12s. So these are the groups, these are all fixed cards. Groups, fixed cards, fixed values. So if we return this, it would be upset because it's like, what are fixed values? You never told me what that was. There's a really nice Elm function called list.partition where we can separate fixed values and wildcard values. So just to show you what I mean by that, we can say list.partition. And what list partition does is it takes a list and it splits things on a condition. So if we say we're going to split where the value is 1, because 1 is our joker value. That's our wildcard value, right? So what we want to do is take the values as they were, split them here, and then what we'll see is if we return that, there were no wildcard values in this, and then all of these were seen as like actual fixed values. But if we change what we have up here to make t, for example, a j, what it's going to do is it's going to separate the j out into its own list, and then it's going to keep the fixed values here. So as we group these values, we run this through the group function, what we'll end up with is only groups for the fixed cards. We're not going to be grouping together the j's. So you'll only see that there's 1, 2, 3, and 4 cards here. And what we can do is we can sort this by the length. So what I want to do here is I want to say list.sort, and I want to make it so that sort by, I think sort, I don't think sort's going to work the way I want it to work. Yeah, sort is going to sort like lexigraphically, so it's not going to sort by how long this list is, it's going to sort by the lowest number. So we're going to do a sort by, and this is going to take in each pair. We're going to sort by the list. So what you'll see here is that the ones that showed up the least frequently are in the front, and the ones that showed up, the biggest groups are in the back. So one trick I'm going to do here is I'm just going to negate that, and that's going to sort it the other way. So up front, we're going to have our 2 3s, which was the most pairs we had, again, when we were dealing with that first input. Sorry, time. Let's see if there's some green light. So 3 was the thing that showed up the most, so we want that in the front for our fixed group. And so what this will allow us to do is it'll allow us to take that first item and say, let's add how many wildcard values we had. So if we take our wildcard values, we can say wildcard value count is going to equal how many we found. So for some puzzles, or for some hands, the wildcard value count, which is an int, is just 0. For the groups of fixed cards, this is what's coming in as input. So in our puzzle, we only have 1 joker, but this number could be bigger if we had a lot more jokers. So if we did JJ, for example, it would be, so here, what we're going to do is we're going to take our groups of fixed cards. We are going to do a list indexed map. And it's going to look just like the list map we had before, except now we have access to the index. And we can say, if you're the first element in this list, so if your index is 0, then we're going to do the list length +1, but we're also going to add the wildcard value count. So if there's a joker, we're going to add 1 more to your group. And if not, we're just going to do the standard list length +1. So what this leaves us with is hopefully the final answer here. So I'm going to down here, we're going to have groups of fixed cards here. Let's think we'll have the groups that we want. So now, because we had 1 wildcard that's a joker, we're seeing that we have a 3 of a kind, which is the 3 3s. If we had 2 jokers, we would see 4 1 as our answer, which is great. And what's cool about this is, oops. What's cool about this, let me just file, is we can reuse the toRank from groups function at the very end here and just treat it as if we always had these lists. So now instead of spitting out that weird list thing before, we can reuse our logic and say, hey, note this is a 3 of a kind. And so we get to keep that, And now we have the ability to add this back on. ToRank is valid again, which means if this is actually returning a rank, then we're good to pass it into this handInfo constructor, which means we're good to return it to handInfo. And if we have the handInfo, we're good to sort it again. We're good to multiply it by the bid, and we're good to sum it. The only important thing is that I make sure that this input from before goes back, because I was fiddling with that for the first example. And we don't want that head anymore. I think we want to wrap this in parentheses. That automatically got removed when I did that latest format. So now it's saying 5905, which is the answer that they came up with in the puzzle. So it looks like we're at least making it work for this puzzle input. Let me just scroll, make sure there's no commented out stuff here. I think this is a helpful comment. I'll leave that in. And all the solutions here I'm going to have in the description of the video if you want to check them out. So I'm going to save this. And what we're going to do is we are going to plug in our puzzle input and see if this solution works with the big puzzle. File, I get 253657168. If we get this right, we just did a week straight of admin of code in Elm. Ooh, answer's too high. Let me see. Looks like this isn't right. There's one thing that I kind of noted. Joker. Two jokers. The ranks. You must have done something wrong. Oh, man. I really thought that would be it. Make sure that I have the correct answer for this part. Make sure that I didn't accidentally like hit a key, mess up my answer. Okay, I did do something wrong. Something bad happened. Oh, okay, now it's working. The heck. All right, so that's good. Let's try it again with the puzzle input. Oh, it's already saved. Like the answer was wrong. 253657168. That's what we typed in before. So what are the new total winnings? Here's what I'm going to do. I'm going to make sure that the reason we got those numbers right was like with this, I'm just going to slow down a little bit. Make sure that all the ranks that I see are what I expect. So 1 pair, 2 pair, and 3 fours of a kind. Let's just like test some stuff out. So I expect this to be 5 of a kind. I thought that would be the answer. And it's annoying that it's right for the puzzle input, because now I need to figure out what's wrong here. So let's take in some of this puzzle input. Let's see if anything is not expected. We're just going to do a little bit of debugging and see where this goes wrong. All right, so it looks like there's one high card. Let's see if we can identify the high card. I don't have to do that. Let's see. It looks like this got a 2 pair, which is right. There's 2 4s and 2 9s. This one got a high card, 6 7 5 9 4. This one got a 1 pair. Yep, the 1 pair is 2 2s. This one got a 3 of a kind. Yep, the J with the 2 7s. This one got a 1 pair. Yep, 2 4s. This one got a full house. It did. And then 3 more 1 pairs. This J bonded with one of these, doesn't matter which, to get a pair. This 2 T's gave me a pair, and these 2 T's gave me a pair. So I think that's right. As long as it's the same. Okay, where do we leave off here? So we did 7TQ all the way down right before these Q's. I'm just going to go through and see if anything here is off. 1 pair. Yep, J with something. This is a 3 of a kind. Yep. This is a 5 of a kind. Sevens. Should be another 3 of a kind. Yep. And then we have 2 pairs. QQ33, KK22, 999. Back to 3 of a kind. 2 pair is 7272. High card. All these are unique. It should be a 2 pair. We have a 3 of a kind after that. 36436. This is all good. Like everything so far is good. I'm like trying to figure out where logic's wrong. Maybe there's nothing wrong with this first part. Okay. 111, 222, 222, 333. A full house 5 of a kind. And just to verify that that's right, let me take one of these 1 pairs. There. Looks like the ranking is correct. If I have 2 numbers that are the same, these are both seen as 4 of a kind. Oops. But this one is lower. Starts with J. Used by what could be wrong here? Same, trying to be whatever card is best for the purpose of determining hand type. You oh, this thing ends with 403. Sweet. 1,000 lines, or like 900 lines of this stuff. Seems okay. Do is the hand info. So X comes in, we're gonna do a debug.log. Sorry, this is just me like doing some debugging. Let we're gonna have the before length. this as is. The after length, and then we're going to keep going. So hopefully the before and the after are the same. The same length. So I'm going to look at the logs here, compile. Yeah, so it looks like before and after we both get 1,000. That's good. So confused. Why would this not be right? Pull input data. It's too high. Well, that's annoying. So when I go to card value, one of these things, didn't see any issues with the ranks that I was given. What about this? The first thing that's not equal to the, give me the first less than or greater than, basically. Not give me an equals. Oh man. I don't know. I'm very surprised. I thought that was going to go really smooth at the end. And then for some reason we had a snag. Just on the last day too. Last day for me. Sure, it's something obvious that I'm just skipping right over. Resort, right? Oh, this is after the sort. What did I do? This is so, it's so hard to like scroll through all this text too. Let's just make sure all my bits are. Seven. Parsing, okay. It seems fine on the parsing side. Something that's all J's. See something that's all J's. You know what I mean? J, 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 J. That's what it is. That's the one thing I screwed up. If it's all J's, it's a 5 of a kind. That's the one part of the logic that's missing. All right, let's add that back in. Gosh dang it! I knew it was something so stupid. I didn't handle one edge case. We found it. All right, that makes me happy because that would have been a real pain in the butt. Always an edge case. That's life, you know. That's just living. Okay. So what I want to do is say if puzzle is just, oh my goodness, there's so much text. How do I delete this? Let's go to hand info. Boom, 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 boom. So here we said it's 3, 2, 10, 3, 12. It's a one pair. 1, 2, 3, 4, 5. I did not consider the case where they're all here because it thinks it's a high card because of the way that I did the grouping. So what I need to do is have one exception. If the wildcard count value equals 5, then it's 5 of a kind. 5 of else. These 3 lines of code. So it screwed me up. All right, that is the correct answer. Final answer, I have confidence now. Oops, I should probably put in the old puzzle input here. Out for the final video. Not map to bid. That. So 5905, that is correct. I was gonna say, like, everything was so normal, like what didn't I account for? And that was it. The 5 jacks. And I like how I tried to search for it and then it didn't even come up in my editor just to mess with me. 2532 53225. Smaller. And that's the right answer. We did it. All right, 1 week. 1 week of Advent of Code, 1 week of Advent of Code Now. Hopefully in the future I can do more structured educational content. Let me know in the comments if that would be something you'd be interested in. Like going through like basics, like syntax, how to use Elm practically. A lot of these, it's like we're diving deep into like complicated problems that take like 30 minutes to an hour to solve. And so I feel like I'm always rushing to make sure that that video time is low enough that people are able to follow it and get along. But when it comes to like educational content, I don't think that's really what people want. If you're watching the video this long, it's because you want to understand what's going on or you want to understand how I'm thinking about something. Um, and if you did watch to the very end, let me know in the comments below. Thank you so much. It's been fun. This is Advent of Code 2023. We got through 7 days. I'm gonna have to call it there because the problems are only gonna get more confusing, and I gotta enjoy my December. You know, it's just how it's gonna be. But hopefully, I'll see you next year for Advent of Code 2024. And goodbye.